Here in session 112, geometric sequences. We're going to be taking a look at those in greater detail. Just as we did with the arithmetic sequences, for the geometric sequences we're going to have two different formulas. One that's going to tell us how to find the sum of the first n terms in a geometric sequence, and the second one showing us how to determine what the nth term is in a particular geometric sequence. So here's our geometric sequence over here at the right, 4, 16, 64, 256, and it keeps going on. And remember, a geometric sequence is this number sequence whereby you have to multiply each term by the same number in order to get the following term. So in this situation, we had to multiply each term by 4. 4 times 4 is 16. 16 times 4 is 64. And 64 times 4 is 256. So the question here, first of all, would be, what is the sum of the first 4 terms in this geometric sequence? Well, these numbers are small enough, and since they're written here for us, we can actually bypass the formula, just line these up and add them up. And we can double check our work this way, but I like to do it through this particular formula to show you how it works so that you'll be comfortable using the formula with much larger numbers that you can't calculate so easily. So S, once again, means the sum of. We're talking here about the sum of a geometric sequence, and N represents the first N terms. So the sum of the first N terms in this geometric sequence is going to be equal to T1, which is our first term, multiplied by R. R is the rate that we have to multiply each number by to get the next one. So our rate is 4. We have to multiply each term by 4 to get the next one. 4 to the n power, well, n here is 4 again. We're trying to take a look at the first 4 terms. So 4 to the 4th minus 1 over 4 minus 1. With that said, let's go ahead and just actually plug in the values and see what we get. The sum of the first 4 terms in this particular geometric sequence is going to equal T1, which is our first term, 4, times, what's our rate? What do we have to multiply each term by to get the next one? 4. And we are raising it to the nth power. Well, what's n equal? N equals 4. We're trying to find the sum of the first 4 terms. So that's going to be 4 to the 4th minus 1 over r minus 1. R is 4, minus 1 is 3. Now then, let's go ahead and calculate this out. The sum of the first 4 is going to be equal to, well, what is 4 to the 4th? Well, 4 first is 4, 4 squared is 16, 4 to the 3rd is 64, 4 to the 4th is 256. So it's going to be 4 times 256 minus 1. Well, 256 minus 1 is 255. So let's go ahead and write the 255 in there. And then we are going to take that and divide it by 3. Now, before we carry this out, everything here is being multiplied. So let's take a look at 255 and see if it will cancel with 3. Do we have a common factor? Well, if you remember your divisibility rule for 3's, it says take the number, or take each of the digits and add them together. 2 plus 5 is 7, plus 5 is 12. Is that 12 divisible by 3? Yes. Therefore, 255 is also divisible by 3. So we could rewrite this as 4 times 255 divided by 3 is 85. And then on the bottom, we just simply have a 1, because when we cancel out the 3, we're left with the 1. Well, 4 times 85 equals 340. So the sum of our first 4 terms in this geometric sequence is 340. Now, we can double check it just by adding these. Since we see the 4 here and the first 3 are relatively small, let's just add them. 4 plus 16 is 20. 20 plus 64 is 84. So now let's take the 256, that's the next term, and add it to the 84. And as you'll see, that equals 340. So this formula does in fact work, and we were able to double check it here. Now before we move on to the next screen, let's just take a look at one more example here. This time the question is, what is the sum of the first 12 terms in this geometric sequence? Well, now we're getting much bigger. We're not going to be able to do this very quickly if we just are trying to add them, because we're going to have to determine what the next 8 are and then add them, and it's going to take longer than to just use the formula. So the question here is the sum of the first 12. We're going to solve this completely with our formula. T1 is our first term, that's 4, times R, our rate is 4, we're having to multiply by 4 to reach our next term, so our rate is 4, and we're taking it to the n exponent. Well, n is 12. And then we're going to subtract 1 from that. And then in the bottom, we're going to have 12 minus 1, which is 11. There's your answer. In most cases, that would probably be good enough. Otherwise, if you have a calculator, you could calculate 4 to the 12th. And then after you get that number, insert that number here into this formula and calculate the rest of it out. But for our purposes right now, what is the sum of the first 12 numbers in this geometric sequence? The sum is going to be 4 times 4 to the 12th minus 1 over 11. Now let's take a look at the same thing that we did on the previous lesson. In this case here, we're not trying to find the sum of the first n terms in a geometric sequence. We want to determine what the nth term is in this particular sequence. So I'm going to still use the 4, 16, 64, 256 sequence. And once again, that does go on indefinitely. And the question here is, what is the third term in our sequence? Well, obviously we can see it. It's 64. But let's figure it out using the formula. Show you how the formula works. Our third term, n, is going to be 3. Our third term is going to be equal to our first term. Well, what's our first term? T1. Our first term is 4. So we're going to replace a 4 for the T1, and then we're going to multiply it by R. R is our rate. What do we have to multiply by to get our next term? 4. So R is 4. And we're going to take that 4 to the exponent of n minus 1. Well, what's n? 3. 3 minus 1 is 2. So our third term is going to be 4 times 4 squared. Well, what is 4 squared? 4 squared is 16. 16 times 4 is 64. So our third term is going to be 64. And as we can see, that lines up with our third term in the sequence. Now that you see how the formula works, now let's do it for something a little bit more difficult. What is our 12th term? So in order to figure out what our 12th term is going to be, we're going to use our formula, replace 12 for n, T1 is 4 again, times R, our rate is 4, to the exponent of n minus 1. N is 12, so n minus 1 would be 11. So in this case here, our 12th term is going to equal 4 times 4 to the 11th. Well, I'm not going to calculate that out fully, but since we have the same base here, 4 is the same thing as 4 to the first, what would 4 to the first times 4 to the 11th be? It would be 4 to the 12th. So our answer here is the 12th term of this geometric sequence is going to be 4 to the 12th power. Okay, on to our review page here. Here again are the two formulas. The sum of the first n terms in a geometric sequence is determined by the following formula. Sn, S standing for the sum of the first n terms, is going to be equal to T1, which is the first term of your sequence, multiplied by R to the n. R is the rate at which you have to multiply each term by to get the next term. N is the number of terms. So you're taking R to the nth power, subtracting 1 from it, and then dividing that by R minus 1. And lastly, the nth term in a geometric sequence is determined by the following formula here. Tn stands for the nth term of the particular geometric sequence. That's going to equal T1, which is the first term of that sequence, being multiplied by R, which is your rate, raised to the power of n minus 1. Okay then, that'll finish up session 112 on geometric sequences.